Hello, my dear students. Last class I explained about the Maculus method. One beam also I have shown like simply supported beam when it is subjected to the point load at the center. Today we'll solve some problems using this Maculus method. Okay, so let us take this example. A steel girder of uniform section 14 meters long is simply supported at its ends. It carries concentrated loads of 90 kilonewton and 60 kilonewton at 2 points 3 meters and 4.5 meters from the two ends respectively. Calculate the deflection of the girder at the points under the two loads, then the maximum deflection. Okay, and here I is given, that is 64 into 10 raised to minus 4 meter raised to 4, and E is equal to 210 into 10 raised to minus 6 kilonewton per meter square. Okay, so here what you have to calculate, you have to find the deflection at the points under the two loads, means you have to find the deflection at C and at D, and also maximum deflection occurs at the center. Okay, because here the load is acting here, so the maximum deflection is at this point, so that also you have to calculate. Okay, first what we have to do, this is a simply supported beam AB of length is 14 meter, and two loads are acting. One load 90 kilonewton is acting at a distance of 3 meter, and 60 kilonewton is acting at a distance of 4.5 meter from B. First step is to find the reaction. What is RA and RB? How to calculate that? Take first summation of vertical forces equal to 0, that is RA plus RB equal to 90 plus 60 here. RA plus RB equal to 90 plus 60 equal to 150. Now, what is the next step? You have to take moment about any point, that is equal to 0. Let us take moment about A, sigma MA, that is equal to 0. So what you will get? This RB into this distance, full distance, that is 14. So minus RB into 14 plus 60 into 9.5 plus 90 into 3. When you write in terms of RB into 14, then it becomes RB into 14 equal to 90 into 3 and 60 into 9.5. That is equal to 840. So RB is equal to 840 divided by 14, so equal to 60 kilonewton. So you have RB, you can calculate RA, because RA plus RB is 150. So RA is equal to 150 minus 60, that is equal to 90 kilonewton. So this is the first step. After that, what you have to do, you have to write one deflection equation. That means you have to take moment at any point or at any section. Okay, so now what we'll do, let us consider any section XX at a distance x from the end A. Following Maculus method, the bending moment equation is given by like this, because see, now I will consider the section here. Okay, suppose the first I'll consider this section here. Okay, so now the section is here. So what is this bending moment at this point? That is RA into this point, RA into, which is at a distance of x. Okay, which is at a distance of x. So RA into x. Next is I consider the section here, this point. So what it is now, the distance you have to consider from here to here is x. So what it becomes, so that is first equation, bending moment at this point is RA into x, plus next is this distance. What is that? I want this distance here from here to here, 90 into this distance. What is that distance? 90 into x minus 3. That is here 90 into x minus 3. Next I will consider here the section. Have to imagine here. Now this is x. Okay, from here to here the distance is x. So what is that? So till here that is there. That is first is RA into x, then minus 90 into x minus 3. Now here I will consider here, that is I want only this distance, that is 60 into x minus this whole distance, that is 6.5 plus 3, that is 9.5. So like this. So my equation at x is mx is equal to, mx is ei into d square y divided by dx square, that is equal to 90x, one this dotted line, then second differentiation minus 90 into x minus 3, then again one more section, that is minus 60 into x minus 9.5. So let this equation be 1. Now you have to integrate this equation. How we will integrate? Once if you integrate this, it becomes ei into dy by dx, that is equal to, so differentiation of x is x square by 2, so 90 divided by 2 into x square, that is 45x square plus c1. You have to add one constant. So this is done. Next this part, again here consider this as a whole term. So x minus 3 whole square divided by 2. So divided by 2, it becomes 90 divided by 2, 45. 45 into x minus 3 whole square minus, then third one is this, that is 60. Again consider this as a whole term. So x minus 9.5 whole square divided by 2. So 60 divided by 2 is 30. So this is equation 2. Now again integrate this. This gives, this is a slope equation dy by dx, and this is deflection equation y. So ei into y is deflection equation. So that is equal to, again integrate this. So x square is x cube by 3. So x 45 x cube by 3, 3 45 divided by 3 is 15. So 15 into x cube plus c1 into x, differentiation of constant, that is into x, plus c2, one more constant you have to add, minus this, again differentiate this, integrate this, that is x minus 3 whole square, that is consider this as a whole term. So x minus 3 whole cube divided by 3. So 45 divided by 3 is 15. So 15 into x minus 3 whole cube minus, again this is integrate x minus 9.5 whole square. So it becomes 3 divided by 3. 30 divided by 3 is 10. So this equation is 3. Now what you have to do? You have to find at different points deflection under the load and also at the center. So what you have to do first? Now you have to consider x equal to 0, means L is equal to 0 that time, at that point only. Then where the support is there, there will be deflection is 0. So y is equal to 0. So substitute in this equation. So what we will get? This is 0, this is also 0, this term becomes 0, this term becomes 0, this term becomes 0, this term becomes 0. So remaining is only C2. So C2, that is equal to 0. Next condition is x is equal to for the whole length, that is first we consider x is at this point A. Now we are considering x is at B. So that whole distance x is equal to 14 meter. That time y is equal to 0 only, because at the support deflection is always 0. So y is equal to 0. So substitute these values in this equation, that is deflection equation. This is the deflection equation. So what it becomes? So 15 into x is 14. So 14 cube plus c1 into again x is 14. This you have to consider, minus 15 into x minus 3. 14 minus 3 whole cube minus 10 into x is 14 minus 9.5 whole cube. To simplify this, you get C1 is equal to minus 1448.84. This is C value. So hence now substitute the C1 value in this equation. So what we will get, write this equation using all the values, that is this equation EI into Y is equal to 15x cube plus C1 is 1448.84 plus C2 equal to 0. So that is 0 into 15 into x minus 3 whole cube minus 10 into x minus 9.5 whole cube. So this is a deflection equation. Now we have to calculate at under the load, that means at C and at D and also at the center. So let us calculate first at C. How this is the now equation, you have to use this equation only. So this is the because here it is calculated what is by taking x equal to 0, y is equal to 0, x is equal to 14, y is equal to 0. So we got the value of C1 and C2. Once if you substitute this, this is our standard equation. Now let us find at C. Okay, so what is distance at C? What is x at C here? This is point. So x is equal to now 3. So x is equal to 3 and you have to find the deflection. Here the deflection is not equal to 0 because it is not at the support. Only at the support deflection is 0. So here there is some deflection that you have to calculate. So how we will calculate? Take x is equal to 3 and substitute in this equation. So what we will get? EI into yc equal to 15 into 3 cube, x is equal to 3 minus 1448.84 into x, that is x is 3 into 3, then this 15, x is 3, so this term becomes 0 and here x is 3, so this is minus value comes, so you can neglect this, so only the equation is till here. Okay, so simplify this, you get this value minus 3941.52. Then calculate what is yc. So yc is equal to minus 3941.52 divided by ei. So substitute ei values, you get yc is equal to minus 2.93 mm. So this is at C because the deflection is value is negative, so this you can say it is downward deflection. Similarly, now you have to calculate deflection at D. So what is that? yd. So here x is equal to this distance 3 plus 6.5, that is 9.5. So now x is equal to 9.5 and substitute in the same equation. Okay, so ei into yd now equal to 15 into, here instead of 3 it is 9.5 minus 1448.84 into this equation x is equal to 9.5 minus this 15 into 9.5 minus 3, so that is here 15 into 9.5 minus 3, and next is this x is 9.5, so this will not be there, so it becomes 0, so only this. Simplify this, you get yd is equal to 3.73 mm. Now deflection under the loads are calculated. Now next step is to find the maximum deflection, that is at the center, means it is not exactly at the center because here two loads are acting, so we don't know what is the exact distance. That has to be calculated first. How we can calculate that? Take the slope equation. Slope equation is ei into dy by dx, that equation. Consider that equation, and here substitute this dy by dx equal to 0, because where the deflection is maximum, their slope is 0. So if you substitute here 0 and this whole term becomes 0, so this equation equal to 0. So only one unknown you will get, that is x. So once if you get x, the x is 6.87 meter. Now you can use this x is equal to 6.87 and substitute in the deflection equation as we have done in the previous calculation. How we have calculated at C and D, same thing, only the x value differs here, that is 6.87. So simplify, you get y maximum is equal to 4.